Hi everyone, we're going to try a slightly different style of video with this one. In this particular video we're going to go through revisiting the structure of the atom as a way to then lead into when we start talking about why the periodic table is arranged the way that it is and why we see certain patterns in chemistry. Okay, so in this one we're going to talk through the broader kind of the general sort of structure of the atom. I'm using a whiteboard here, so I'm going to be sketching as we're going. So I apologise if that ends up being a little disorienting. I'll try to be as gentle as I can. So the general kind of structure of the atom and the different parts we find in the atom, and then start looking at a little bit more of the fine detail of that of the model that we use. Okay, so remember that the word atom, when we're talking about atoms, we're talking about these particles coming from this Greek word atomos. So we were talking about meaning indivisible. This idea that it's a particle that they previously thought could not be broken down any further, couldn't be cut. It was, if you took a substance and you broke it into the smallest pieces, eventually you'd get to a point at which you couldn't do so anymore, and that would be atomos, where we get our modern day concept of the atom. Okay, we now know, because science has progressed further in the hundreds of years since that first concept came about, that actually not only can atoms be broken apart, but they're made up of smaller parts inside them. Okay, that we call subatomic particles. Okay, so particles, or kind of little pieces that are smaller than the atom itself, and so we'll go through some of those. Okay, so we're thinking here, alright, so we've got a very general kind of structure of the atom here. Okay, that looks a bit like this. Alright, so we have, here we've got the center of the atom. Remember that we call that the nucleus. And then around the outside of the atom, that we have represented by this dotted line, it represents the electrons. Electrons orbiting around the nucleus. Okay, so we visualize it like planets going around the sun. Okay, now it's not a perfect kind of concept. There's things that explains and things that it doesn't, but it's a helpful idea for us to jump off with. Okay, and so the nucleus being in the center. Okay, and that it's being positively charged, and so positive. That's a little shorthand for positive. And our electrons orbiting around the outside are negative, and so our atom is neutral overall. Okay, so overall the atom does not have a positive or a negative charge, but the parts inside it do. Okay, and so then what we see, if we take the nucleus and we kind of expand it out, this sort of picture, is it's actually made up of all of these particles kind of inside it. So what we've got two types of particles. We've got protons and we've got neutrons. Okay, so protons have a positive charge, and then neutrons have a neutral or zero electric charge. Okay, so that's kind of, if we take that nucleus and we zoomed in further, we would see these subatomic particles. When we're talking about protons and neutrons as kind of where we find them, we use the term, you don't have to know this off by heart, but we use the term nucleons, just because they're particles that we find inside the nucleus. Okay, now they're different from each other, but we both say they're both nucleons. Okay, but so protons have a positive charge, neutrons have a neutral or zero charge, electrons have a negative or minus charge. Okay, so that what we see is that in order for our atom, so remember we're talking about this concept of it being neutral overall. That means the number of protons equals the number of electrons. Okay, so let's visualize it like this. Okay, so kind of a seesaw, or maybe a set of balancing kind of scales over here. Alright, so if I'm going to see if I can represent with different colours here, bear with me. Alright, so if I've got an atom that I know has 3 protons, I'll see if I can draw little plus signs in them to represent our protons. Okay, then that means in order for it to be balanced that I would need 3 electrons. My this marker's not, it's a dodgy one, so you can't see the minuses quite so well. Okay, but so what we have is we've got 3 on this side, we've got 3 on that side, so it's balanced. Okay, now we'll come back to this concept in a future video when we start to think about, okay, well, what happens if we could artificially tip that balance, take one out of the electron side? What does that do? Okay, and so we'll get to that in due course. But okay, but so we see that we've got an atom that's neutral overall, we've got protons, which means therefore that the number of protons equals the number of electrons in an atom. So if I've got 3 protons, I need 3 electrons. If I had 30 protons, I need 30 electrons. If I had 100 protons, I need 100 electrons. You get the idea. Okay, it's not that hard to grasp once you kind of take that central concept. Okay, so just to quickly kind of recap some of the key terms that we've talked about here, we've reintroduced the concept of the nucleus. We've talked about subatomic particles. So the nucleus being the part at the center of the atom that has most of its mass. It only takes up a small volume, but it has most of its mass. We've got 3 types of subatomic particles that we particularly care about. Protons, which are positive, neutrons, which are neutral, and electrons, which are negative. And the number of protons equals the number of electrons, which makes it neutral over all. Okay, that wraps it up. Thanks very much for watching. Bye for now.